So I want you to imagine interacting with an AI that doesn't just, you know, process the characters you're typing on a keyboard. Imagine it actually grasps the physical limitations of the room you're sitting in right now.
Oh, wow. Yeah.
Right? Like an AI that understands gravity, fluid dynamics, even the tension in a boardroom or the unspoken rules of human interaction. We're talking about a system that doesn't just read about the world, but actually comprehends the physical and social realities of it.
Which is, I mean, it's a complete departure from how we currently think about computing, isn't it?
Yeah.
We're so used to systems that force us to translate our messy three-dimensional reality into flat, structured data.
Yeah, prompts, code, spreadsheets.
Exactly. So an AI that natively understands our world on our terms, that fundamentally changes the definition of what a machine is even capable of doing.
Okay, let's unpack this.
Yeah.
Because today's deep dive is looking at a really thought-provoking roundtable discussion from Technology Review. And it dives straight into this massive, honestly almost philosophical question: can AI truly learn to understand the world?
It's a huge question.
It really is. And the panel features Technology Review Editor-in-Chief Mat Honan, Senior AI Editor Will Douglas Hebben, and an AI reporter. And they are essentially charting the course from the current limitations of artificial intelligence to this entirely new architectural horizon.
And, you know, to understand that horizon, we really have to look at the structural ceiling hitting the current generation of models. The panel, they do a great job grounding the discussion in a reality check.
Right, because we all know what large language models, or LLMs, can do.
We know they can synthesize like vast amounts of text, write functioning code, summarize complex legal documents, all that stuff.
Yeah, it feels like magic sometimes.
It does. But there's a growing consensus that simply scaling up these models, you know, just throwing more compute and more text at them, it's yielding diminishing returns when it comes to actual real-world utility.
Wait, really? Diminishing returns already?
Yeah, because they are fundamentally bottlenecked by a lack of contextual comprehension.
Okay, we should probably define what we mean by contextual comprehension here, because it's super easy to confuse a model's ability to generate a highly articulate essay on 18th century economics with genuine understanding.
Right. Sounding smart isn't the same as being smart.
Exactly. The analogy I keep coming back to is, well, current LLMs are kind of like someone who has memorized an entire encyclopedia.
Right.
But they have absolutely zero street smarts.
That's a perfect way to look at it.
They can process the data, they can recite facts, but they don't know how to navigate a room.
Yeah.
So is this lack of real-world application, is that the ultimate ceiling for LLMs?
In their current form, yes. Because, like your analogy points out, the AI is essentially operating entirely within a latent space of language. They've perfectly mapped the statistical relationships between words. But let's say you were to drop an LM into the brain of a robot navigating a busy coffee shop.
Oh man, it would be a disaster.
Instant failure. I mean, it knows the word coffee often appears near the word spill, sure. But it doesn't intuitively grasp the physics of a liquid falling to the floor, or the spatial reasoning required to, you know, step around the puddle so you don't slip.
Let alone the social tension of an overworked barista dealing with a long line while there's a mess on the floor.
Exactly. Because text is an incredibly low bandwidth, lossy projection of reality. When a human writes, "The cup fell off the table and shattered," we don't bother writing down that gravity pulled it down.
Or that the floor was tile instead of carpet.
Right, or that the impact created a loud noise that made people jump. We just assume the reader knows the physics. But an LLM only has the text. It only knows that shattered is a highly probable token to follow fell off the table.
But wait, I have a pushback here. If the problem is a lack of data about how the physical world works, why is this a hard ceiling? Why can't researchers just, synthesize billions of data points explicitly detailing physics, fluid dynamics, and social etiquette, and just feed that into the next iteration?
Because reading a description of a physical law doesn't create a causal engine.
Meaning what, exactly?
Well, the tech review panel highlights that processing text data about a coffee shop is fundamentally different from maintaining a dynamic state of a coffee shop.
Ah, okay.
LLMs are autoregressive. They look at the previous sequence of tokens and guess the next one. They don't track the continuous state of objects over time.
So if you tell an LLM, a character, put a ball in a box, carried it to another room, and turned it upside down.
The model has to rely on statistical language patterns to guess where the ball is. It isn't maintaining a 3D coordinate system in its architecture. So without that grounded comprehension, it's severely limited.
Which means it can draft a flawless business plan for a logistics company, but it has no idea what to do with the unpredictable friction of a truck actually breaking down on an icy highway.
Exactly. It's completely blind to reality.
So simply reading a trillion more words won't teach an AI how gravity or object permanence works. What will? Because the AI community clearly isn't throwing in the towel here.
Far from it. The tech review editors point to a massive architectural shift designed to solve this exact problem, which brings us to world models.
Okay, world models. What does this all actually mean? From what the source material is saying, a world model aims to equip AI with the ability to simulate and interpret the complexities of the real world, right?
Yeah, that's the core of it.
So going beyond processing data to grasping subtleties, let me try an analogy here. Is a world model basically an internal flight simulator for the AI? Like, is it running simulations of environmental variables in its head before it makes a decision?
What's really fascinating here is that your analogy is spot on. Think about the difference between looking up wind patterns in an encyclopedia versus running a high-fidelity flight simulator.
Okay, yeah.
A traditional LLM is the encyclopedia. It's impossibly fast, but it's just mapping your prompt against a static database. A world model, though, operates as a simulator. It's trying to build a working, dynamic representation of an environment.
I want to push on that flight simulator analogy a bit more, because I think it highlights exactly how this works under the hood.
Go for it.
A flight simulator doesn't just have a massive lookup table of, what happens when wind hits a plane at a 45-degree angle. That would require infinite data.
Right. Impossible to store.
Instead, the simulator has a physics engine. It computes the fluid dynamics of the wind against the shape of the wing in real time. If you change the weight of the plane, it doesn't look up a new text file. It recalculates the physics.
Precisely. And the world models discussed by the panel are trying to build that kind of computational engine for everyday reality, which requires a shift from predicting words to predicting states.
Predict states. So if I ask an AI with a world model a complex question about a physical environment,
it isn't just generating the most statistically likely text response. It actually runs a simulation of the scenario you described. It updates variables, mass, velocity, spatial relationships, and observes the outcome in its internal model before it ever generates a word to tell you the answer.
Okay, which makes total sense for physics. Modeling gravity and velocity is a math problem. A wildly complex one, sure, but still math. Where this gets incredibly thorny for me is the panel's assertion that world models aim to grasp subtleties like human interaction and cultural nuances. Simulating a falling coffee cup is one thing. Simulating the social dynamics of the people watching it fall. How do you even parameterize social friction?
And that right there is the ultimate bottleneck the industry is wrestling with right now. Encoding physical laws is basically a solved problem in video games. But encoding human reality.
Yeah, how do you do that?
It means teaching a system that, say, silence in a boardroom in Tokyo might signify deep respect and agreement, but that exact same silence in a boardroom in New York...
Oh, that means the deal is falling apart.
Exactly. It requires an AI to understand context entirely divorced from the literal words being spoken.
But this is where I really have to call out the fundamental premise of the tech review discussion. Isn't simulating human culture fundamentally impossible because reality is a moving target?
What do you mean?
Well, physics doesn't change. Gravity tomorrow is the same as gravity today, but culture shifts every single day. Generational slang evolves. The baseline for what's polite or offensive in an email shifts year by year.
Oh, absolutely.
So by the time researchers encode a cultural nuance into a world model, it's already outdated. How do they plan to build a simulator for a reality that won't sit still?
That is the crux of the representation challenge. You can't hard code cultural rules for exactly the reason you mentioned. They decay instantly.
Right.
So the solution the field is pointing toward isn't about giving the AI a static rulebook of human behavior. It's about giving the AI the capacity to observe variables and update its own internal model dynamically the same way a human does.
Okay, wait. Walk me through that.
Think about it like starting a new job. You don't know the specific social dynamics of the new company before you start, but you have a generalized internal model of human behavior that allows you to read the room, observe the power dynamics, and adapt on the fly.
Ah, I see. So you're abstracting the variables. You aren't teaching the AI the specific rule. You're giving it the architecture to recognize that a rule exists and needs to be learned from the immediate context.
Precisely. And when a model can maintain that kind of dynamic state, whether it's the physical state of a room or the social state of a conversation, it develops something that looks remarkably like intuition.
Intuition.
Yeah.
Wow.
A human expert, like a seasoned diplomat, isn't pulling from a rigid script. They're running incredibly fast subconscious simulations based on their experience. They anticipate how a phrase will land based on the cultural background of the person across the table.
And world models are attempting to give AI that exact capacity for intuitive reasoning.
Yes.
Okay, here's where it gets really interesting. Because if we successfully equip AI with these world models and it develops this intuitive grasp of physical laws and human subtleties, it completely shatters the current paradigm of how we use software.
It changes everything.
The Technology Review Panel highlighted that the ultimate goal of this shift is to move from reactive AI to proactive AI. And that is a huge redefinition for us. Because right now, AI is entirely reactive.
Totally. It sits idle.
Right. It doesn't matter how advanced an LLM is, it does
Yeah.
absolutely nothing until a human types a prompt and hits enter. We are the cognitive engine. The AI is just the transmission.
And the limitation of a reactive tool is that it requires the user to hold the entire context of the world in their head. Let's say you use a current model to plan a major supply chain logistics pivot.
Okay.
You have to explicitly feed it every constraint. You have to tell it the current port capacities, the weather forecasts, the labor union regulations. You act as the world model, and the AI just formats your understanding into a strategy.
But an AI that natively possesses a world model shifts that cognitive burden entirely. It already tracks those environmental variables.
Exactly.
Which means it doesn't have to wait for you to ask the question. A proactive agent observes, anticipates, and acts autonomously. But, I mean, you can't have a proactive agent without a flawless world model.
Oh, definitely not. If a purely text-based LLM tried to be proactive, it would be a disaster.
It would just be randomly firing off emails and executing code based on statistical guesses.
Yeah, to be proactive without being destructive, the system needs that internalized simulator to predict the consequences of its actions accurately.
So let's apply this to that global supply chain logistics example. Currently, an AI can react to a disruption, right?
Right. So a massive storm shuts down a major shipping lane, humans input that data, and the AI recalculates the fastest alternative routes. It's essentially GPS routing on a macro scale.
But a proactive AI, equipped with a comprehensive world model, operates on an entirely different timeline. It is constantly running forward-looking simulations. It tracks the atmospheric variables forming the storm days in advance.
Yes, and if we connect this to the bigger picture, it isn't just a weather model. It cascades those variables into its economic and cultural models, too.
Oh, wow. So it simulates the storm hitting the port.
Calculates the resulting backlog, cross-references that with the labor variables at alternative ports to ensure they can handle the overflow, computes the fluctuating fuel costs of the diversion.
And then proactively reroutes the cargo ships before the bottleneck ever even materializes.
Exactly. It doesn't tell you how to clean up a mess. It prevents the mess from happening.
Taking that down from global logistics to the consumer level makes it even more tangible, I think. We're talking about an AI acting as an autonomous chief of staff. If it has a working model of your environmental variables, your physical location, traffic patterns, the time of day, and it understands human subtleties, it fundamentally changes how it manages your life. Let's say you're stuck in gridlock and you have a crucial client meeting in 20 minutes.
A classic nightmare scenario.
Right. A reactive AI does nothing until you open an app and dictate a message. But a proactive AI, running its internal simulator, recognizes the causal chain. Traffic equals delay, delay equals missed meeting equals damaged client relationship.
And it computes the optimal intervention. It doesn't just draft an apology email. It might analyze the client's past communication style to determine if a formal email or quick text is more culturally appropriate.
It adjusts your calendar, pulls up the relevant files for the meeting so they are ready the second you arrive.
And reroutes your navigation. All initiated without a single prompt from you because its internal model realized the current trajectory was going to result in a negative state.
But this brings us to a massive, glaring tension in what the tech review editors are proposing. As technology transitions from reactive to proactive, we are forced to surrender an unprecedented amount of control.
A terrifying amount, honestly.
Yeah. When a system is reactive, no matter how complex it is, you maintain absolute authority over when and how it intervenes in your workflow. You pull the trigger. When an AI becomes a proactive agent, constantly running simulations and acting on its own computed intuition, You are placing an enormous amount of blind trust in its internal world model.
You are trusting that the AI's parameterization of reality aligns perfectly with your own, and that is a monumental leap of faith. The panel emphasizes that building a world model is not just a challenge of scale, it's a challenge of representation.
Meaning, how accurately can it actually reflect us?
Exactly. How accurately can a neural network encode the messy, often contradictory, highly subjective nature of human existence?
Because if its cultural model is slightly off, the proactive actions it takes could be disastrous.
Oh, 100%.
If your AI chief of staff misreads the social dynamics of an email thread and proactively cancels a meeting that was actually a high-stakes negotiation disguised as casual banter.
The efficiency of the AI suddenly becomes a huge liability. We're asking these systems to navigate invisible rules that even humans routinely get wrong.
Right. We spend our entire lives refining our own internal world models just by existing in society, making mistakes and facing the social friction of those mistakes.
We are essentially trying to reverse engineer the human experience of reality and encode it into a computational architecture. The last decade of AI development was fundamentally about teaching machines how to speak.
And we mapped the structure of language incredibly well.
We did, but the insights shared by Honan, Heaven, and the rest of the panel make it clear that language was the easy part. The next decade is about teaching machines how to live in the physical and social world alongside us.
Which means the current generation of LLMs isn't the finish line. It's barely the starting line. The transition from predicting the next word to predicting the next state of reality requires a complete architectural teardown.
It is the foundational requirement for the next era of computing. Until an AI can simulate the physical weight of an object, the progression of time, and the causal chain of human interactions, it will always be an impressive parlor trick constrained to a two-dimensional screen. World models are the mechanism that will allow AI to step out of the text box and actually operate in 3 dimensions.
Bringing this all together, the Technology Review Roundtable paints a very clear picture of where we are and where we're going. We are currently hitting the ceiling of text-based models. They're incredibly articulate, but fundamentally blind to the physical laws and social friction that govern our reality.
They know the map, but they have never set foot in the territory.
Exactly. And the proposed solution is this shift toward world models, architectures designed to simulate reality rather than just retrieve data about it.
By maintaining dynamic states of environmental variables and cultural nuances, these models aim to develop genuine causal reasoning and intuition.
Right. And the ultimate payoff of that architectural shift is the leap from reactive tools to proactive agents. Systems that understand the world well enough to anticipate our needs, compute optimal outcomes, and act autonomously to navigate bottlenecks before we even know they exist.
It fundamentally shifts the burden of understanding from the human prompting the machine to the machine observing the human.
But before we wrap up this deep dive, I want to leave you with something to ponder that extends beyond the technical challenges of state spaces and physics engines. We're talking about a future where world models become sophisticated enough to flawlessly simulate our deepest cultural nuances.
It's wild to think about.
A future where an AI can proactively anticipate your emotional state based on microscopic human cues and adjust its behavior to provide the exact social friction or lack thereof that you need in that moment. So if we successfully build an architecture that can perfectly simulate empathy, tension, and understanding, will we eventually lose the ability to tell the difference between a machine's calculated simulation of care and genuine human connection?
That's the real question.
And if the simulation is completely flawless, perfectly adapting to your reality, does it even matter that there isn't a human on the other side? Something to think about. Thanks for joining us, and we'll see you on the next Deep Dive.